Through the periscope of the Japanese submarine I-36, Lieutenant Commander Takeshi Matsumura witnessed something that would fundamentally challenge every assumption Tokyo had made about American industrial capabilities. The date mattered less than what his eyes were recording in that moment, scanning the American anchorage with mounting disbelief. His hand trembled slightly as he adjusted the focus, trying to comprehend the scale of what lay before him. The American fleet anchorage wasn't simply a collection of warships at rest. Instead, Matsumura found himself staring at what could only be described as a complete industrial metropolis floating upon the Pacific waters. His training at the Imperial Naval Academy had prepared him for many scenarios, but nothing in those years of instruction had suggested the possibility of what now filled his field of vision. 6 enormous floating structures dominated the lagoon, each one dwarfing any dry dock facility that existed anywhere in the Japanese home islands. Matsumura's breath caught as he observed one of these massive installations holding the battleship Alabama, the great warship lifted entirely clear of the water's surface, its massive hull exposed and covered with swarming teams of workers and their equipment. Another of these floating giants cradled 2 cruisers at the same time. The Americans hadn't simply brought their fleet to the war zone. They had transported their entire shipbuilding infrastructure across thousands of miles of ocean. The notebook tucked into Matsumura's breast pocket would soon contain sketches and detailed observations that would send shockwaves through the Japanese High Command when they finally reached Tokyo. That night, as Matsumura composed his coded transmission to headquarters, he wrote words that would echo through Japanese naval planning offices for months to come. The Americans were repairing their damaged vessels faster than Japanese kamikaze pilots could inflict damage upon them. This wasn't warfare as the Imperial Navy understood it. This represented a mathematical equation that Japan simply could not solve or overcome. The structures Matsumura had observed through his periscope were auxiliary floating dry docks from the AFDB series, each one manufactured in sections at different American shipyards scattered across the continental United States, then towed piece by piece across the vast Pacific to be welded together like enormous steel jigsaw puzzles at forward locations. AFDB-2 alone measured 927 feet in length and possessed the capability to lift 90,000 tons of dead weight. When fully manned and operational with its complement of 600 personnel, the facility contained complete machine shops, working foundries, comprehensive electrical repair facilities, and storage capacity for 65,000 gallons of fuel oil. The dock generated all its own electrical power, distilled its own supply of fresh water, and operated with the organized efficiency of any major naval shipyard located on American soil. What Lieutenant Commander Matsumura couldn't possibly observe from his submerged vantage point were the additional revelations that would have completely shattered Japanese naval doctrine had he known their full extent. Scattered across the breadth of the Pacific Theatre, 7 major advanced base sectional docks and 31 smaller auxiliary floating docks were transforming every captured atoll and island into a potential equivalent of Pearl Harbor itself. 3 weeks before the attack on Pearl Harbor launched the Pacific War, Vice Admiral Osami Nagano had stood before his colleagues in the conference room of the Japanese Naval General Staff Headquarters in Tokyo, presenting what appeared to be flawless final war plans. The calculations seemed mathematically sound and strategically reasonable. American naval infrastructure on the Pacific coast consisted of 8 major shipyards. The facility at Mare Island in California could handle simultaneous work on 4 capital ships. Puget Sound Naval Shipyard up in Washington state could manage 3 such vessels at once. Pearl Harbor's facilities in Hawaii, the closest American base to the anticipated war zone, might handle perhaps 6 major repairs simultaneously under optimal conditions. The mathematics appeared to favor Japanese strategy. If Imperial forces could successfully damage or sink 20 American capital ships during the first 6 months of conflict, the Americans would require at least 18 months to complete repairs and construct replacements. Damaged vessels would need to steam 3,000 miles back to the Pacific coast of the continental United States. The journey alone consumed 2 weeks in each direction, removing ships from combat operations for multiple months. Admiral Isoroku Yamamoto, despite his private reservations about initiating war against the United States, had approved these estimates. His operations officer, Commander Kameto Kuroshima, had prepared extensive charts demonstrating American industrial capacity. The United States had produced 1.5 million tons of merchant shipping during 1941. Japanese shipyards had produced 400,000 tons during the same period. Naval construction represented something different, Kuroshima insisted during his presentations. Warships required specialized facilities, highly skilled workers with specific training, and particular materials not needed for merchant vessels. The bottleneck constraining American naval repair wouldn't be raw industrial power or manufacturing capacity, but rather dock space and dedicated repair facilities. The Japanese High Command had never imagined the possibility that Americans would simply construct entirely new shipyards and then float those facilities directly to the battle zone itself. The history of American floating dry docks traced back to commercial necessity and earlier innovation. During 1927, the United States Navy had commissioned its first self-propelled floating dry dock, designated YFD-2. Unlike traditional fixed dry docks carved from granite and reinforced concrete, floating dry docks operated on fundamental ballast principles familiar to any submarine officer. Pump water from the ballast tanks and the structure rose. Flood those same tanks and the dock sank beneath the surface. A damaged ship could sail directly over a submerged dock, which would then be pumped out to lift the vessel completely clear of the water for hull repairs. By 1940, American naval planners recognized that this technology, if scaled to massive proportions and made genuinely mobile, could eliminate geography as a limiting constraint in naval warfare. The Bureau of Ships initiated what seemed like an impossible program even to experienced American engineers. They would build floating dry docks large enough to handle battleships. These facilities would be constructed in transportable sections for ocean transit. The design would allow them to operate independently in the most remote locations imaginable. The Advanced Base Sectional Dock Program represented American industrial organization, expressing itself at its most audacious and ambitious. Different sections would be constructed at different facilities across America. Section A would be built at Everett Pacific Shipbuilding up in Washington State. Sections B and C would come from Chicago Bridge and Iron Company facilities in California. Sections D through G would be fabricated at Mare Island Naval Shipyard. Each individual section weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth. 10 sections welded together would create a floating dock capable of lifting a full Iowa-class battleship entirely out of the water. The engineering challenges appeared almost insurmountable to the teams assigned to solve them. Each section needed sufficient structural strength to withstand Pacific storm conditions during the long towing journey across open ocean, yet had to be machined with precision, allowing it to be welded to neighbouring sections with tolerances measured in mere millimetres. The ballast systems installed in each section had to operate in perfect synchronisation with all the others. The docks required fully equipped machine shops capable of manufacturing any replacement part imaginable, from massive propeller shafts to precision gun barrels. Each facility needed to be entirely self-sufficient for extended periods. Commander Tamichi Hara, captain of the destroyer Shigure, witnessed American repair capabilities firsthand when his vessel engaged United States forces near Tulagi during March of 1943. In his post-war memoir, he recalled the confusion and disbelief that gripped Japanese officers. His destroyer had successfully damaged the cruiser Helena with a torpedo strike. Japanese intelligence reports confidently predicted the vessel would require 6 months in a stationary dry dock for proper repairs. 3 weeks later, reconnaissance photographs showed Helena at Tulagi, fully operational, her guns actively firing at attacking Japanese aircraft. The Japanese couldn't comprehend what they were seeing. Where was the massive dry dock required for such repairs? Aerial reconnaissance showed only empty ocean and small coral islands. The Helena had been repaired by ABSD-1, assembled at Espiritu Santo just weeks before the engagement. The massive floating dock had lifted the 10,000-ton cruiser completely clear of the water, repaired the 20-foot gash torn in her hull, and returned her to active service in just 19 days. The identical repair performed at Yokosuka Naval Arsenal in Japan would have consumed at least 4 months under optimal conditions. Captain Hara's confusion reflected a fundamental misunderstanding that plagued Japanese naval planning throughout the entire war. Japanese military thinking conceived of naval bases as fixed installations with permanent facilities constructed over decades of patient work. Yokosuka Naval Arsenal, Japan's premier shipbuilding and repair facility, had been under continuous construction and improvement since 1866. The Americans had somehow created equivalent capability in merely 6 months and then floated that capability directly to the front lines of active combat. Admiral Chester Nimitz grasped immediately how floating dry docks transformed the fundamental arithmetic of attrition warfare. In a detailed memorandum to Admiral Ernest King, dated January 15, 1943, Nimitz articulated the strategic revolution with characteristic clarity. The availability of floating dry docks in forward areas fundamentally altered the correlation of forces in ways that traditional naval calculation couldn't capture. A damaged ship repaired in 3 weeks at Ulithi versus 3 months back in San Francisco represented not just a time savings, but a 4-fold increase in available force strength across the entire theatre of operations. The Japanese High Command discovered this new reality gradually, through accumulated evidence that defied their original calculations. The Battle of Santa Cruz in October 1942 had inflicted severe damage on the carrier Enterprise. Japanese naval intelligence estimated 6 months minimum for proper repairs to such extensive damage. The Enterprise reappeared in active combat operations after merely 30 days, having been repaired at New Caledonia by the destroyer tender Vestal, working in cooperation with advanced base facilities assembled on location. Rear Admiral Matome Ugaki recorded his bewilderment in his private diary. The enemy's repair capabilities exceeded Japanese intelligence estimates by factors that defied explanation. Ships that Japanese forces had confirmed as severely damaged were returning to battle before Japan's own lightly damaged vessels could complete repairs at home facilities. By early 1943, the United States Navy operated an extensive network of floating repair facilities that had transformed the entire Pacific theater into American-controlled territory. Advanced base sectional docks had been established and were operating at Espiritu Santo, Ulithi, Leyte Gulf, and Manus. Smaller floating dry docks serviced destroyers and submarines at dozens of additional locations scattered across captured atolls and islands. The construction statistics alone revealed Japan's increasingly hopeless strategic position. Mare Island Naval Shipyard was simultaneously producing multiple ABSD sections while building brand new destroyers and cruisers on adjacent slipways. The facility employed 46,000 workers operating 3 complete shifts, 24 hours every day. During just 18 months, Mare Island alone produced more floating dry dock capacity than Japan's entire permanent dry dock infrastructure accumulated over 80 years of development. Lieutenant Commander Haruki Iki, a trained naval architect working at Yokosuka Arsenal, conducted a comprehensive analysis of American repair capabilities during early 1944. His report calculated that American floating dry docks deployed across the Pacific could simultaneously accommodate repairs on 18 capital ships, 36 cruisers, and over 100 destroyers at the same time. Japan's entire domestic repair capacity could handle 6 capital ships, 12 cruisers, and 40 destroyers under optimal conditions. More critically for Japanese strategic planning, Iki identified what he termed the multiplication effect of forward repair capabilities. A ship damaged at Leyte Gulf and repaired at nearby Ulithi returned to active combat in 1/4 the time required for a vessel that had to sail all the way back to Japan for repairs. His conclusion carried devastating implications that he stated with stark clarity. Japan was fighting an enemy who had successfully brought his homeland industrial base directly to the battlefield itself. Japanese forces simply could not sink American ships faster than the Americans could repair them and return them to service. The floating dry docks achieved their first truly spectacular public demonstration during the invasion of Kwajalein in February 1944. The battleship Maryland absorbed kamikaze hits that tore a 40-foot hole in her main deck. Traditional naval doctrine would have required sending her back to Pearl Harbor, removing the vessel from combat operations for multiple months. Instead, Maryland sailed just 240 miles to Majuro Atoll, where AFDB-2 was waiting and fully operational. The massive dock, commanded by a Commander Joseph J. Rochefort, who was not the famous intelligence officer of the same name, submerged its working deck beneath the surface, allowing Maryland to carefully position herself over the precisely placed keel blocks. Within 4 hours, powerful pumps had expelled 8 million gallons of seawater, raising the 45,000-ton battleship completely clear of the ocean surface. Captain Yoshitake Miwa, commanding submarine M184 on patrol in the area, observed this operation and immediately radioed headquarters in Tokyo. Maryland was entering the floating dock at Majuro. Extensive damage was clearly visible to observation. His estimate indicated minimum 3 months would be required for proper repairs to such severe damage. 3 weeks later, Maryland departed Majuro under her own power with full combat capability obviously restored. Captain Miwa's follow-up report carried an almost desperate tone. The Americans had somehow made time and distance strategically irrelevant. Commander Mochitsura Hashimoto of submarine WAD 58 later wrote about the psychological impact of this phenomenon on Japanese submariners. Japanese submarines would successfully attack an American carrier or battleship, carefully calculate the months that would be needed for proper repair based on known damage, only to encounter that exact same ship weeks later in fully operational condition. It felt like fighting against mythical creatures from ancient legends that possessed the ability to heal their wounds instantly. AFDB-7, operating at Leyte Gulf, demonstrated complete overhaul capability when it received the carrier Franklin after that vessel suffered devastating kamikaze damage during March 1945. Franklin had absorbed the most severe damage of any American carrier that ultimately survived the entire war. 807 sailors had died in the initial attack and subsequent fires. Standard naval procedure would have classified Franklin as a total constructive loss not worth the effort of repair. But AFDB-7's crew of 1,000 included certified specialists in every conceivable aspect of ship construction and repair. They operated continuous shift schedules that literally never stopped, working around the clock. Master Chief Petty Officer William Delaney later provided testimony about the operation. The crew essentially rebuilt that ship from the inside out, he explained. In a stationary yard with full facilities and unlimited resources, it would have represented a 6-month job at absolute minimum. The floating dock crew completed the work in 11 weeks while operating in an active combat zone subject to air attack. Lieutenant Commander Sadao Kusaka flew reconnaissance missions over American advance bases throughout 1944. His April report revealed the depth of strategic shock rippling through Japanese naval aviation. He had observed Ulithi anchorage in extensive detail during a high-altitude mission. Initial count identified 6 large floating structures that had previously been classified as possible cargo vessels or oilers in earlier reconnaissance reports. Upon much closer examination during this mission, these structures were clearly identified as mobile dry docks of unprecedented size. One currently contained the battleship Iowa, with her hull completely exposed for repair work. American maintenance capacity wasn't fixed to geographical locations, but had become genuinely mobile. The Americans were literally bringing their industrial bases with them as their forces advanced. Admiral Somu Toyoda, who had assumed command as Commander-in-Chief of the combined fleet following Yamamoto's death, received these accumulating reports with growing desperation about Japan's strategic position. At a staff meeting during May 1944, he presented his senior officers with the brutal reality of inevitable defeat. If the Americans could repair their ships 3 times faster than Japanese forces could, then Japan would need to sink 9 enemy ships for every one Japan lost just to maintain equilibrium. This mathematical requirement was simply impossible to achieve. Japan was being defeated not by American ships or sailors, but by American floating steel and superior industrial organization. Each dock section included complete living quarters designed for its assigned crew, equipped with bunks, full galleys for meal preparation, and comprehensive medical facilities. Seaman First Class Robert Leckie, assigned to AFDB-3 at Manus, later described daily life aboard these unusual floating installations. Here they were, thousands of miles from home, living aboard this massive steel structure floating in the Pacific. The crew held regular movie nights projected against the dock walls. When no ship occupied the dock, baseball games were organized on the bottom floor. They weren't simply repairing damaged ships. They represented a floating piece of American homeland transplanted to the war zone. The food served aboard floating dry docks became legendary among sailors throughout the Pacific Fleet. While combat ships subsisted on Spam and reconstituted powdered eggs, the dry docks maintained extensive frozen food lockers and operated full bakeries with trained bakers. AFDB-2's Thanksgiving dinner during 1944 served 2,000 complete turkey dinners with all traditional accompaniments to crews of damaged ships currently under repair. Vice Admiral Takeo Kurita experienced the strategic impact of floating repair facilities firsthand during the Battle of Leyte Gulf in October 1944. His battle plan had assumed that damaged American ships would necessarily withdraw from the combat zone for repairs, progressively weakening the invasion force over time. Instead, damaged vessels simply sailed short distances to nearby mobile repair facilities and returned to the battle line within mere days. Kurita later wrote about his frustration and confusion. Japanese forces would inflict significant damage on an American cruiser, reasonably assume that vessel was eliminated from combat for weeks, only to face that exact same ship actively fighting just 3 days later. Japan wasn't fighting just the American fleet, but rather the entire American industrial system, which had somehow been made portable and mobile. The most remarkable rapid repair feat had actually occurred earlier with Yorktown at Coral Sea and Midway. Yorktown arrived at Pearl Harbor severely damaged from the Coral Sea engagement on May 27, 1942. Admiral Nimitz gave repair crews exactly 72 hours to restore combat capability. The carrier entered Dry Dock No. 1 on May 28. 1,400 workers from Pearl Harbor Naval Shipyard labored continuously around the clock without pause. Yorktown sailed on May 30th with her flight deck patched and her boilers operational. The ship was combat-ready, though Japanese intelligence remained absolutely convinced Yorktown was still under repair back at Pearl Harbor. When Japanese pilots at Midway reported attacking a third American carrier, Admiral Nagumo's staff simply couldn't accept the report as accurate. Lieutenant Joichi Tomonaga transmitted before his death that the Americans possessed 3 carriers in the battle, where Japanese calculations indicated only 2 were mathematically possible. By mid-1944, American floating dry docks had effectively transformed the entire Pacific Ocean into an American maintenance highway with repair facilities positioned at regular intervals. Ships damaged during operations at Iwo Jima could be repaired at Guam. Vessels struck during the Okinawa campaign found floating docks waiting at Karama-Retto. Commander Sadatoshi Tomioka calculated the strategic impact in terms that highlighted Japanese helplessness. The enemy had effectively eliminated distance as a factor in naval warfare. A ship damaged at Formosa could receive repairs at Leyte faster than Japanese forces could repair a ship damaged at Leyte and return it to Sasebo. Japan was fighting an enemy who had made geography strategically irrelevant through industrial innovation. Between 1942 and 1945, American shipyards produced 7 advanced base sectional docks and 31 auxiliary floating docks of various sizes. The combined lifting capacity of all these facilities exceeded Japan's entire permanent dry dock capacity by a factor of 4. Each ABSD cost approximately $40 million to construct and deploy to forward locations, roughly equivalent to the cost of a light cruiser. Yet each dock could repair dozens of cruisers during its service life. Rear Admiral Kizo Kimura captured the psychological impact in his private diary. The Americans were constructing floating dry docks the size of city blocks and then towing them across the Pacific Ocean as if already certain of ultimate victory. They were building the infrastructure of peace while Japan was still desperately fighting the war itself. Chief Petty Officer Marcus Thompson worked as a hull repair specialist on AFD-B2, having completed 18 months of intensive training at Mare Island before deployment. His specialized team of 40 master welders could repair torpedo damage that would have challenged the capabilities of major shipyards back in the States. Thompson recalled after the war that they had become artists of destruction repair. A destroyer arriving with her bow completely blown off presented no insurmountable challenge. The team would fabricate an entire new bow section in 5 days flat. The medical facilities maintained aboard floating dry docks added significant strategic value beyond pure ship repair. Each major dock included a fully equipped hospital with operating rooms and surgical staff. Dr. Lawrence Steinberg served as Chief Medical Officer on AFD-B1 and performed over 200 major surgical procedures during his deployment, treating both combat casualties and industrial accidents. During November 1944, submarine Saui 365 received specific orders to penetrate the defences at Ulithi and attack the floating dry docks rather than targeting warships directly. The mission reflected changing Japanese priorities and growing recognition of the dock's strategic importance. The submarine was detected and destroyed before reaching Ulithi, becoming one of 6 Japanese submarines lost while attempting to attack floating repair facilities. The only partially successful Japanese attack occurred on April 22, 1945, when Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at 14,000 feet altitude, managed to damage ABSD-2's Section G during a kamikaze attack. The dock's crew completed all necessary repairs within 3 days and returned to full operational status. Commander Masataka Okumiya conducted analysis of these failed attacks and reached a disturbing conclusion from the Japanese perspective. Japanese forces could occasionally inflict damage on individual warships, but the floating dry docks seemed to multiply like living organisms reproducing themselves. The docks weren't simply floating repair facilities, but rather floating factories that possessed the capability to reproduce their own capacity through repair and expansion. The Okinawa campaign from April through June 1945 witnessed the most concentrated damage infliction of the entire war. Over 400 American ships sustained damage from kamikaze attacks during this brutal campaign. A fleet of floating dry docks positioned at Karama Retto operated continuously throughout the battle, sometimes lifting damaged ships for repair while still under active air attack. Captain Toshiyuki Yokoi, commanding kamikaze operations from land bases, recorded his growing despair in official reports. Japanese pilots were sacrificing their lives to damage American ships, only to see those exact same vessels returning to combat within days. The floating dry docks represented some kind of American industrial magic that Japanese forces had no effective counter for. Of 404 ships damaged during the Okinawa campaign, 387 returned to full operational status without ever returning to permanent bases in Hawaii or on the American West Coast. The destroyer Laffey, struck by 6 separate kamikaze aircraft on April 16th, was fully operational again by May 1st. Captain Minoru Genda reviewed captured American planning documents after the war concluded and was stunned by what he discovered. The Americans had intended to deploy 12 major floating dry docks and 40 smaller ones to Japanese home waters for the planned invasion. Even if Japanese forces had managed to damage half the American fleet on a daily basis, the Americans could have repaired those ships faster than Japanese gunners could reload their weapons for follow-up attacks. Working with battle-damaged ships meant handling unexploded ordnance and exposure to toxic smoke from fires. On AFDB-3, 7 workers died when a weakened bulkhead suddenly collapsed during repair operations on the heavy cruiser Pittsburgh. Yet crew morale aboard the floating docks remained consistently high throughout the war. The official motto of AFDB-2, painted in letters 10 feet high along the side of the structure, read simply, "We keep 'em fighting." Admiral Somu Toyoda's post-war interrogation by American officers identified 3 decisive factors that he believed had led to Japan's ultimate defeat. American submarine warfare had strangled Japanese supply lines. Fast carrier task forces had achieved air superiority. And floating dry docks had made American naval power essentially indestructible. Regarding the third factor, Toyoda stated with remarkable candor that American floating dry docks had killed the Japanese Navy as surely and effectively as American bombs and torpedoes. The Americans had made time and distance strategically irrelevant. They had successfully brought their homeland's complete industrial power directly to Japanese home waters. Between 1943 and 1945, American floating dry docks performed 1,847 major ship repairs and 8,234 minor repairs across all Pacific locations. They successfully returned 95% of all damaged vessels to full combat service within 30 days of arrival at the facility. Commander Joseph Rochefort, the intelligence officer whose code-breaking efforts had helped secure victory at Midway, offered his perspective on the strategic impact. The Japanese leadership believed they were fighting against American ships and American men. They were actually fighting against the entire American industrial system, which had been successfully made portable and deployable. Every floating dry dock represented Detroit and Pittsburgh made manifest in floating steel. The organizational vision driving this achievement came from officers like Rear Admiral Ben Morrell, who understood that American industrial superiority meant absolutely nothing strategically unless that industrial power could be projected directly to the point of conflict. His vision transformed industrial capacity from a homeland advantage into a deployed weapons system that could be positioned anywhere American forces operated. Mare Island Naval Shipyard employed 6,000 women by 1943, breaking traditional gender barriers under wartime necessity. Marjorie Muller worked as one of the first female welders assigned to ABSD-2's Section F. She understood that every perfect weld she created meant American sailors would survive battles and return home. The Chicago Bridge and Iron Company employed 4,000 African-American workers at its California facility, where they constructed 3 complete ABSD sections, achieving production rates that actually exceeded some integrated yards operating with traditional all-white crews. Admiral Arleigh Burke frequently cited floating dry docks in his lectures as premier examples of American innovation and adaptability. The Japanese forces brought superior training and tactical excellence to the Pacific War. Americans brought floating dry docks instead. The Japanese made the ocean into a battlefield. Americans made it into a factory floor where industrial production continued without pause. Japanese naval attachés stationed in the United States had filed reports on American shipbuilding capabilities throughout the 1930s, but they interpreted everything through the lens of their own experience and assumptions. Commander Yoshiro Fujimura had visited Chicago Bridge and Iron facilities and directly observed sectional construction techniques. His report back to Tokyo noted that Americans constructed industrial plants like children's toys, building them in sections designed for later assembly. He found it interesting but ultimately irrelevant to serious naval construction. As the war drew toward its conclusion, American floating dry docks were still being manufactured in ever greater numbers. AFDB units 8 through 14 were actively under construction for the invasion of Japan that ultimately never occurred following the Japanese surrender. The complete story of American floating dry docks represents 2 fundamentally different concepts of power meeting in direct conflict. Japan conceived of power in traditional military terms, emphasizing warrior skill, fighting spirit, and tactical excellence developed through rigorous training. America conceived of power in industrial terms, emphasizing production capacity, logistical superiority, and repair capability. The Pacific War tested these competing visions under the harshest possible conditions. Once American floating dry docks had been successfully deployed across the breadth of the Pacific theater, each one represented the entire American industrial system made mobile and deployable. They embodied Detroit's assembly lines and Pittsburgh's steel mills transported directly to the battle zone. Against such concentrated industrial might deployed at the point of contact, no amount of traditional military excellence or warrior spirit could possibly prevail. Admiral Soemu Toyoda's final assessment after Japan's surrender captured their ultimate strategic significance with brutal honesty. The Americans had defeated Japan the moment their floating dry docks first arrived in Pacific waters. Japanese forces could sink American ships through superior tactics and tremendous sacrifice, but the Americans could raise those ships, repair them, and return them to battle. The floating dry docks meant Americans could absorb any level of losses and continue fighting without pause or weakening. The Pacific Ocean itself had been transformed into an American lake, not because American forces controlled every square mile of water, but because Americans possessed the capability to maintain their forces anywhere in that ocean, at any time, indefinitely. Japanese commanders came to realize they weren't fighting against ships and planes and men, but against an entire industrial system that had somehow learned to float across oceans and deploy itself wherever American forces needed support.